Well, welcome back, everyone. Now we're going to proceed with the first module, which is Voice over LTE Network Architecture. So, Charles, can you tell us what are the objectives for this module?
Glad I can, Joan. In this module, we're going to be looking at what is voice over LTE? Why do we need it? And we'll look at the architecture both from the 3GPP standpoint and Nokia's implementation of that 3GPP standpoint.
You say first here, what is the need for voice over LTE? So I want to know more about that. And can you tell me what are the options for voice over LTE?
Sure. First of all, we have to know what voice over LTE is. Voice over LTE is based on voice over internet protocol, or also known as VoIP. And what we're doing is we're taking a system that was pure, we had two different parts to the network. We had the voice side and then we had data side, and we've combined them into a single voice over, and that's what LTE has been doing, voice over network data. And so we're working on voice over LTE as an implementation of this voice over IP, but over the LTE network, which requires that we have real-time traffic with quality of service to ensure that our voice quality remains the same, yet still remain able to interact with other technologies such as CDMA 2000 or GSM or UMTS's networks.
I see that here on the slide it's saying that it doesn't include the traditional 2G, 3G voice services. What exactly would those services mean?
Well, this would be the voice services, talking about a regular telephone call, but it would not be over a dedicated radio path for those voice services. We would be moving it from those voice services over an actual data network instead of over a dedicated circuit switch path.
I'm wondering what are some of the advantages of using voice over LTE over other cellular technologies?
Well, I'm glad you asked. There's lots of different aspects here, and so I'm probably going to touch a couple slides here quickly. First of all, in the options for voice, when we talk about voice over LTE, we do have the ability to set it up for what we call circuit switch fallback. This is a standard. Now, that allows the subscriber to, when it wants to make a phone call, go back to a previous technology such as GSM or UMTS or CDMA 2000. It is also a IMS voice VoIP or voice over LTE using the IP multimedia subsystem for straight voice. That means it's going to be all over packet. Now, one of the things that is standardized in the 3GPP. The last option that is actually not set up as a standard, it's actually called simultaneous voice and data, where we allow the subscriber to do both voice and data, and how we implement it as manufacturers is up to us. It's not set by the standard. This is how you will implement it. So that's why we call it non-standardized, yet it is very possible to be using those technologies. Now, you asked about what are the reasons, why are we doing this, is because voice over a packet network allows us to have an increased spectrum efficiency. In other words, I can get more things into the same space as I would use because I'm using less overhead, or I'm using I'm using more frequency, and allows me to be more efficient in the way I do the spectrum. That's spectral efficiency. We're talking about more voice calls per megahertz wide of carrier. We're looking at higher data speeds compared to other older technologies like UMTS. Also, because we have wider spectrum, higher data throughputs, and we're using data, we're able to have a much higher voice quality, and we'll have a better setup for the voice quality. Okay, we're talking about factors of a 1.5 times greater than what we had during circuit switch type calls. Okay, the other one is we can also allow the subscriber to have more than just voice. So we can do things like video and voice together through the IP multimedia. That's why we emphasize multimedia subsystem. So we can do much, much more than just voice over LTE. It's voice over LTE is only one of the many possible services that we can offer.
Can you tell us who uses voice over LTE today?
Lots of different people are using it. Now, this is just a few of the people. So, for example, we have full LTE coverage in Korea. They have full voice over LTE coverage and have been using it for several years. In the United States, we've been using it many different places. Now, this is showing just AT&T, but the reality is LTE over the last years has been definitely spreading, and I have much better coverage than we used to. It's not sparse anymore. It's becoming fully covered. In Japan, the big cities for sure have it, but they are again expanding because these graphics come from a couple years ago where it was still early in the development of voice over LTE, yet now we are using it extensively in some of our locations. Canada has it. That's being implemented in some places in South America. So it's many ways we are using it all over the world. Now, it depends on how our implementation is working. So, for example, many of the countries in Latin America are utilizing the circuit switch fallback. That means they're not really using voice over LTE. They're using a fallback to the previous technology like 2G GSM so that it can communicate, so that the subscribers can use the phone and make phone calls over an existing network, helping the operator continue to utilize the equipment they already have, yet have higher speeds of data than what GSM gives us, which is very low.
Charles, I'm more familiar with the 3GPP architecture. Can you tell me what is the difference between the 3GPP architecture and the voice over LTE solution?
First of all, let's look at what the solution architecture looks like. So this is a typical VoLTE, and it's only showing a very small portion of the full architecture. Our typical LTE network is here. So we have our subscriber, we have our LTE node B, and then we have the EPC core. This is what we've been using, and it's just a straight packet data network for accessing. Now, we like to divide it into 3 parts. First of all, the terminal. That's the subscriber, also known as the UE in our network. The eNode B is really the access. It's the radio access portion of the network. And in our case, we call this the EU-TRAN. Now, the EPC core and the IMS core and the CS core, we tend to call this the core network. Now, in the EPC core, that was where we already had it. We had gateway, we had the serving gateway, and we had the packet data network gateway, or PGW. We have our mobility management entity that allows us to have mobility. We had the policy charging rules function, which allowed us to set quality of service. Now, these were all authenticated utilizing something that was a part of the IMS core, or IP multimedia system core, called the home subscriber server. Now, that home subscriber server is really a big authentication mechanism for the network. Now, what we've done with voice over LTE is, instead of putting the circuit core in parallel out to the access network, what we've done is we've moved that access network behind the packet data gateway. So now we're using data to flow our system, our audio, our services, our packets, our web browsing, whatever it happens to be, all of that flows through, and then we can implement, in this case specifically, higher quality so that we can have voice over this packet network, and then we can prioritize our packet utilizing quality of service over this network. Now that means we have something called the IMS core. Now that IMS core is going to provide the signaling for establishing a voice call. We use a protocol there called Session Initiation Protocol, or SIP. That's going over this link called GM. Now the voice itself will flow over the data path. That means it's a data flow, and it uses a protocol called real-time protocol. Obvious name because it's real-time traffic that we're carrying. In this case, particularly voice, but it could be video, it could be something else over that real-time protocol. Now, to get to the public system, or public telephone system, that telephone network, we would actually go through something called the media gateway. And that media gateway would translate from the voice over LTE format into the public switch telephone network, which uses the TDM, or time division multiplexing network. Remember, it's not just voice. We are able to carry voice or many other applications over this network. Okay, so let's look at your question about 3GPP versus Nokia's implementation. The 3GPP breaks every little box, every little function into its own little box. So we have things like the serving call function, and actually if you look at that, there's 1, 2, 3 versions, actually 4 versions of this serving call function. This is the controller that sets up our voice. We have our application server. Well, guess what? One of our applications is voice. These are using SIP, Session Initiation Protocol. The serving call function is going to handle all of the signaling. The application server is going to take and provide a service of some kind. And then they will connect with various boxes to the public switch telephone network. Now, we at Nokia implement this system by combining certain functions that are in 3GPP into a box. So for example, here we have something called the CFX 5000. That's hardware in which we implement the border control function, or BCF, which contains the ATCF, the PCSCF, and the IMS ALG. Now, if you want me to remember all of those particular acronyms, that's where I go to the 3GPP and look them up. But this is called the proxy call serving call function, and that forms a proxy for the signaling. And that was one of the icons that we had over here, the proxy call serving call function. Now that CFX 5000 also contains the other versions of the call serving call function and the border gateway control function, the BGCF. Now there's a whole ton of these. If you'll notice, we have the HLR, we have the HSS, HLR home location register, HSS home subscriber server, and each piece of hardware marked in the yellow box performs its function in some way. That's our basic Nokia architecture.
This is quite a bit to absorb. Can you give a close-up view of how Nokia is implementing this solution?
In the Nokia implementation, here I said the CFX 5000, it's going to contain many of the functions that are for signaling. So if you really want to call that the core of the IMS, it is the core of the IMS. It's the one that's handling the signaling, and it's very similar to the functions that are happening in the MSS, or the mobile subscriber system, which is what controls the 3G and 2G type technologies. So it's the mobile subscriber system, or the mobile MSS, we call it. Used to call it the mobile call center, or MSC. And this handles the connection with other technologies like GSM and UMTS. And some of the functionality is built into that the MSS. Now, the CSCF, or the call serving call function, is a function within the server called the CFX 5000, and it will provide the services to the subscriber. Now, if you follow the lines here carefully, it comes through this various connections. Here's the SGI link. There's a and that comes down to the access gate portion. So we have our PDN, or Packet Data Network Gateway, and then our serving gateway. We have our MME and our eNode B, and then our subscriber sits out over the air from that evolved node B. Now, to apply voice, to really do voice over LTE, we have to implement some kind of application server. So that's what the AS is in TAS. TAS means telephony application server. Now, we have a couple ways that we've implemented this. The telephony application server that we use in this network is called an open TAS. So it's an open standard, but we're following the open implementation of the 3GPP standard to ensure that we are interoperable with other technologies. Now, all of this is going to have some kind of database that has to back it up. So that's where we have in Nokia, we have something called the 1NDS. Provides the heavy database so that the telephony application server can access what it needs to determine if the subscriber can or can't do those services. The call serving call function assures that the subscriber is authenticated. The MSS actually talks to this 1NDS because it's talking to the home location register function. The home subscriber server that the MME uses is also a part of the HSS functionality, the home subscriber service functionality, which is all part of the 1NDS network.
Charles, there's a few things on this slide I wanted to understand a little bit more, like peer, PLMN.
Great question. The BGW is a border gateway. Okay, the border gateway is basically a router that connects to the public LAN mobile network. For example, that's what the PLMN is, the public LAN mobile network. You might also call it the public switch telephone network, PSTN. And the peer would be another network just like this somewhere else. So if I'm going to talk between one provider and another provider, and they both happen to have voice over IP, then we don't necessarily need this media gateway to do the changing of voice from one format to another. We may, or we may not. That's what this border gateway is all about, to determine that, negotiate that, to determine whether we can actually use voice over IP between the subscriber in our network and another, and that's why we call it peer network. So it's an equal network, whereas the PLMN really is the telephony network, that is the public switch telephone network, or PSTN.
DNS and INUB, is that some special terms that TAS uses or the subscribers using?
Good questions. DNS has to do with domain name service. What that does is it translates something like www.nokia.com into an actual IP address that the subscriber can use, or that the network server can use to look up something. Now, the INUM is a sort of a function like DNS, but now what we're doing is we're translating a phone number That's why it's called num. So it is like a DNS for phone numbers, so that we can find a TAS server that has a session initiation protocol phone, and able to look up that number and find the server that belongs to it, or that phone number belongs to. That way we can translate a phone number, 1-555-1212, into a address of a voice server, so that we can make a phone call to that voice server.
Operational support. How is that dealt with the voice over LTE when you talk about operational support?
There is no standardized link. All the links that have lines here have standards assigned to them. The operational support section is our Nokia specific implementation of how we monitor the MSS, how we monitor the TAS, how we monitor the CFX 5000. So all of these are connected through the network, but there is no standardized link in the 3GPP as to how to monitor every one of these elements. So these are our implementation. So here's our charge at once. That's a charging server of some kind. The NetAct is actually monitoring for things like faults. It's also for configuration. And as are each one of these. So in some ways, each one of these has a different aspect of what we call the OSS, or the operational system support system. It allows us to actually manage our network, charge appropriately, provision appropriately each one of our network's elements. So they would tie into things like, so for example, provisioning. The charge at once would somehow be tied to the 1NDS. Again, 1NDS is not the standard. The elements inside are the standard. And as I said, each one of these lines in here are actually tied to an actual standard in the 3GPP network.
Can you provide a simpler solution, or simplify the solution for us?
In fact, I'm glad you asked, because really, in many ways, especially when we're dealing with the radio network, we do not need to know all of the tiny little details of absolutely every little tiny function that's in the network. What we need to understand is we have our subscribers, we have our access network somehow, whether it be HSPA with over 3G, GSM or UMTS, or some kind of network, or hey, even over Wi-Fi. We have some kind of access network to connect to the IMS core, which is going to be used to do central session routing. It'll provide the single sign-on services for these devices. It'll provide orchestration of what services you have. And then we have, so in the access network, these two will interact with each other to make sure we implement correct policies, correct charging policies. Also, we'll be able to authenticate the subscriber through all of that. We'll also provide services like single radio voice call continuity, or enhanced single radio voice call continuity in this access network. Now, while the IMS core is doing all of the signaling management, then the application servers up at the top are actually going to provide whatever the application is, whether it be mobile telephony application, also known as OpenTAS. We'll have, so we'd be able to support services for voice. We could actually do video. We could also have the ability to change from an IP-based user into a circuit switch-based user as we move from a VoLTE network, or voice over IP network over LTE, into a non-voice over IP network such as GSM or UMTS or even CDMA 2000. Now, this is a simple network. Simple diagram. We have a server that is providing a service. We have a signaling administration to say, okay, can the subscriber provide the service? And then we have an access network that is giving us access to our devices, whether they be landlines, although we're talking about radio, or cell phones over, or even an application sitting on a laptop.
This is really starting to pull things together for understanding voice over LTE. But now I'd like to know how voice over LTE is it evolving? Can you tell us, talk to us a little bit about how LTE is evolving?
Great question. Because we are evolving. What is LTE? Well, we started out with the regular cellular networks. These regular cellular networks provided by 2G and 3G were providing us both circuit and data. And it may have been that you couldn't do data at the same time you were doing circuit, depending on the configurations of the network. One of the beauties of LTE is while we're migrating through the network, as we start getting more and more coverage, we will move more and more towards voice over LTE. But until then, we have the ability to do circuit switch fallback services. That means we can go back to the other technology. Eventually, moving towards this one voice over LTE in the network. That means we would have everything over data and we have LTE coverage everywhere. And we would be able to have real rich type multimedia services, even something like maybe gaming over this system where we authenticate and provide services as an operator. Until we get there, between the circuit switch fallback and when we have full voice coverage, we will have another ability where we start a call on voice over LTE, and then as we get to we start losing coverage and we have another network available like 2G or 3G, we can actually transition the call from voice over LTE into the other technology. So this evolution is going to continue, but ultimately we are going to come to the place where it all goes over the data network. Every service we have flows over this data network. That means voice, that means our data, so email, web serving, all of that is going to flow over this data network, but particularly the ones that we're going to focus on in this course is more the idea of voice flowing over this data network. And how does the voice affect our data? Or how does the voice affect what we're doing in the network? How do we need to tune the network differently? And that's what our goal is for this course.
Thanks, Charles. I really think I'm starting to understand the basis of voice over LTE, but I know that we only scratched the surface with why we need it, what is it, and how it fits in the system. I'm really looking forward to the other modules to help us understand this technology even more.
Great. I'm looking forward to the next few modules too.